Welcome to this edition of the Times Techies webinar series. My name is Sujit John, and I have with me my colleague Shilpa Fadnis. We are technology and business reporters at TOI, and both of us have been with TOI for a long time. The two of us will moderate this discussion. Our discussion today is on the future semiconductor landscape and the changing paradigm of VLSI education in India. Dramatic changes are happening in the semiconductor space worldwide. On the manufacturing side, the world does not want to be so heavily dependent on Taiwan anymore. So the US, Europe, China, even India, all are trying to develop their own chip fabrication ecosystem. And some are pouring billions of dollars into creating these. On the chip design side, where India actually is very good, efforts are on to develop chips that are optimized to new digital technologies like AI, IoT. Even companies like Google are trying to develop their own AI optimized chips. All of these fascinating changes mean that India needs to really ramp up its skill base in these areas. To discuss these changes, to discuss the requirements of skills, we have with us three distinguished professionals. We have Professor Ramgopal Rao. Professor Rao is the director of IIT Delhi. Before joining IIT Delhi as the director in April 2016, Professor Rao served as the P.K. Kelkar Chair Professor for Nanotechnology in the Department of Electrical Engineering and as the Chief Investigator for the Center of Excellence in Nanoelectronics Project at IIT Bombay. Professor Rao has over 450 research publications in the area of nanoscale devices and nanoelectronics and is an inventor on 45 patents and patent applications, which include 17 issued US patents. 12 of his patents have been licensed to industries for commercialization. Professor Rao is a recipient of the Shanti Swarup Bhatnagar Prize in Engineering Sciences in 2005 and the Infosys Prize in 2013. Welcome, Professor Rao.
Thank you.
We have with us Dr. Satya. Satya has been on this platform multiple times. Satya is the president of the VLSI Society of India. He's also the chairman of IESA. He's the founder and CEO of CDR's Innovation. CDR's is focused on building intelligent electronic products and solutions in the area of medical electronics, agriculture, and environment. Satya has previously worked at Intel for many years. Welcome, Satya. And we have with us Preet Yadav. Preet is the R&D and SOC Technical Program Manager for the automotive business at NXP Semiconductors. Prior to rejoining NXP in his second stint, he worked with Wipro as analog practice head and as distinguished member of technical staff at Wipro, taking care of analog and mixed signal practice globally in the VLSI Technology Group. He leads the Northern Region Electronics Forum in collaboration with India Electronic Semiconductor Association and VLSI. He has 22 publications in international and national IEEE conferences with 3 Best Paper Awards in his name. Welcome, Preet.
Thank you.
Those who are viewing this can send in questions through the Facebook comment box. Shilpa and I will put them to Professor Rao, Satya, and Preet. Let me start by asking Professor Rao, given the big changes that are happening in the semiconductor field, given India's keenness to build a semiconductor ecosystem, given the excitement around new chip designs, how are all of these reflecting in the engineering education field?
Yeah, thank you very much. Thanks for inviting me to be on this panel along with my colleagues. So, in fact, India VLSI design is one area which is of great demand in the academic institutions. If someone is looking for a career today, with a guaranteed kind of a job after graduation, I think one has no doubt, needs to pick up VLSI design as a career. In fact, we are not able to produce as many graduates as what the industry requires right now. And I was also looking at some of the data from Ministry of Electronics and Information Technology. And I think we are a factor of 2, lower compared to what the industry requires. We are talking of something like 500,000 people, the requirement currently, and what we have is half of that. And so there is a huge need for scaling up this area in academic institutions. And but the problem basically lies in finding good quality faculty, because when there is so much of demand for trained manpower in the industry, and for someone to leave an industry job and join academia in these areas is becoming difficult. Even in established IITs like Delhi, Bombay kind of places, we are still short of VLSI faculty. At IIT Delhi, we could recruit tomorrow 10 people, in electrical engineering department alone, if they are available. That's a kind of a thing. And talking of 23 IITs, easily about 500 faculty we could have recruited if they are available. But this is all the quality manpower I am talking of. There are many VLSI programs all over the country. I was also looking at some data where they say only 10% of them, are good enough to start their jobs in the industry. They require a lot of there's a lot of skill gap between what the industry requires and what is happening in the academia. So therefore, industries need to conduct for them very long-term training programs to bring them up to the speed. And so that is one of the major challenges. So if you ask me, the challenge is finding faculty to scale up our programs. And India, on the other hand, has certain advantages. While in the VLSI design area, we have not been able to scale up our manpower requirements or even meet the manpower requirements of industry. In the electron devices area, India is actually doing very well. If you look at the electron devices, the technology and the device design, simulations, these sort of areas, India is currently at the third position in the world after China, US, and India. And there, if you look at top journals in the electron devices area, our share is almost like 15% of the papers come from India alone, and India is doing very well. But the electron devices area is something which is of use more for the technology industries, the ones which are doing semiconductor manufacturing kind of an area. And unfortunately, in India, because of the lack of semiconductor manufacturing, other than in Chandigarh, in the semiconductor lab where some manufacturing happens, we don't have any commercial foundries in the conventional CMOS areas. As a result, all this manpower, the very high quality manpower we are producing in the electron devices area, they all look for carriers abroad. If you go to TSMC in Taiwan, you will have lots of Indian students coming out of these programs, serving TSMC, and they are all basically waiting for some manufacturing activity to start in India so that they can all come back and man these places. So the not having a good commercial foundry is coming in the way for us right now. But when it comes to VLSI design, I think almost every major semiconductor industry will have their largest VLSI design center in India, mostly either in Bangalore or in Delhi NCR region, and they are all doing cutting edge research. Many of the very advanced chips that you use in your whether it is computers or mobile phones or everywhere, I think these chips are all designed out of India. So very high quality manpower, very high quality work, all of that is happening. But I think we need to scale it up. And government target I was looking at was about $50 billion of export in the VLSI design space by 2020. I see that we are half of that right now. So government now is starting special manpower development programs. The Ministry of Electronics has just initiated a program where they are looking at from chips to systems. That is what they are looking at. And so they are talking of achieving a target of $50 billion exports in the VLSI design space. And they want to again ramp up the manpower availability from academia. And Ministry of Electronics and Information Technology is in a way, we are discussing with them, and you will see more and more MTech level programs starting in IITs in the next 1 or 2 years, which are focusing more on the system level designs, because we have many startups, and these startups also have major VLSI design requirements, but neither can they afford the EDA tools, nor can they afford these VLSI designers, because they are competing with Intels and these large companies, and that is an issue. So what government is trying to do is make available this resource for the startups, so that the startups will be able to build a complete systems on chip for a variety of applications. And that is a skill that is now happening in academic institutions. And hopefully I think that capacity building in the VLSI area, and more focusing on the complete system development, the system on chip kind of a development, is the future direction now in academia. And that is mainly keeping in mind the requirements of the startups, because you go to any startup, there is always invariably an electronic component, and these electronics are often on PCBs and all that. What you do today on a PCB is what you want to implement on silicon in your next generation of product development. But that PCB to silicon is a journey that requires, skilled manpower in the VLSI area and access to these tools. Of course, they can, seek services of the fabulous companies which are available, but many of these are still beyond the realm of startups. They cannot afford to do that at this point in time. But that is a gap that one is trying to fill up right now through availability of high quality manpower with system focus, making available EDA tools in large number of institutions, so that the startups can utilize these EDA tools and move to the silicon implementation of whatever products, whatever technologies that they are currently working on. For example, I have two startups myself, and both these startups now are seriously dependent on the VLSI, because one of them is trying to make an entire explosive detection kit on a chip. And when you want to make the entire explosive detection kit on a chip, you need to have multiple diverse components to be integrated on the same silicon platform. And that is a very important and a very involved kind of a task. And similarly for agricultural sensors, even there, to bring down the cost, we again require the silicon implementation. There again, we are working with in multiple ways to realize the silicon ASICs, the application specific integrated circuits, whether it is for agricultural sensing applications or for security applications such as explosive detection. So I see that in two of my startups, these are the two major requirements. I can imagine many other startups looking for similar kind of services.
Very interesting. There's so many interesting points there. I particularly like the point. I had not heard this before. TSMC actually has a lot of Indians working in those foundries there, is it? In Taiwan and all?
They have multiple cricket teams there, playing cricket in the evenings and filled with lots of Indians and mostly.
Really?
Yeah,
This all in Taiwan, is it?
Taiwan, yeah. So.
Wow. Yeah, and I'm
Basically,
like
all the fabs across the world, right? Basically, of Indians, right? Because they have basically primarily very good background, basically from their academic institutions, right? So
they say IC stands for India and China, Indians and Chinese.
Yeah, so it's basically like if you go to Intel, probably you'll find 40% population of India, China. Right?
Okay. There are many interesting points. I will come back to you, Professor Rao. There's already a question also for you from the audience, but I'll come back to that. Satya, jobs in the sector, what? Lots? How does it stand now? Professor Rao already said that
Yeah, so let me qualify some of the numbers which Professor Rao said, right?
Okay.
So, total job market is somewhere basically where it's said, but basically every year about 15% of the basically total job comes from the fresh graduates, right? So if we translate those numbers, that comes to about basically somewhere around 15,000 or so graduates every year we need as a fresh guy for basically serving basically around 60 to 70,000 of total VLSI. When I say VLSI, right, even companies like Intel might have basically 50% people who are in software and embedded systems. So pure VLSI designer, probably about 60 to 70,000 strong in the industry, and about 15% of that basically every year we basically hire as a fresh graduates, either BTech, MTech, and so on and so forth. And Professor mentioned about the SMDP program. Like SMDP program now is basically in the 4th generation. It started basically way back, and currently the 4th generation is being planned. Probably by next year, we will have a new SMDP program. So typically, if you look at the SMDP program, it has about 70 odd institutes which are supported for basically with various type of the facilities, EDA tools, training on these tools, as well as basically some of the faculty workshops and so on and so forth. And estimated basically from the 70 odd institutes, we produce about 10,000 students basically every year from these people, right? But as Professor was saying that basically some of them are basically good quality, some of them are not so good quality, right? So, so if you look from a job point of view, the industry is kind of divided in two pieces, right? One is basically large MNCs, and second is basically services companies, right? So now a large MNCs can basically afford good talent because they are ready to pay those kind of basically money as a basically compensation to these people, which could go nowadays somewhere between basically for a BTech from a reputed institute can go up to like 14, 15, 16 lakhs per annum type of the salary, right? Whereas the service industry can't afford basically that kind of basically remuneration. So they take that basically people from the tier 2, tier 3 colleges where basically salaries may range from basically 4 to 7 lakhs basically as a starting salary, right? So there is a totally two different pockets. But uh, for the people coming from preeminent institutes, right? I think this is one of the very good career. And I think people are getting basically a lot of good jobs. And over the time, right, I think there was a time where when every smart guy from the IITs and premier institute was going towards e-commerce, right? I think the tide is turning back towards the core, basically what we call core jobs. Now people are more interested in the core jobs, basically for the VLSI or whatever their branches, right? I think we are seeing good traction. So there are good jobs available, basically with very cutting edge work happening, basically with these companies. And the demand remains high. I agree with Professor Rao that uh, we need probably better quality in faculties, especially basically in the tier 2 institutes. Tier 1 basically probably still attracts good enough faculty. But the two things, right? If I had to basically extend the thing beyond job a little bit, right? Our intake of the PhD students is basically which determines the future faculty is of not very high quality. And second thing is that basically, unlike a lot of Western universities, right, there is, because of the lack of faculty and so on and so forth, a significant amount of inbreeding happens in basically Indian institutes, right? Inbreeding means like you do a PhD and then you get employed there itself. Whereas basically if you go to the US, it is very strongly discouraged to basically do inbreeding, right? So I think to improve the quality of the education, quality of the people, I think together we have to address both of these issues that PhD intake has to basically become better quality as well as basically faculty. Also, Professor Rao said that we need to get more people with better qualification and help us basically minimize the inbreeding in these institutions.
Okay, okay. Professor Rao, quickly you want to respond to that point about PhD quality? Is what can be done?
The PhD quality, I agree. The one issue is, in this area, unless you have silicon background, I mean, you might have designed a great chip, but unless you get it tested on silicon, you implement it on silicon and do the testing, it really means nothing. You can design something, simulate and claim that you have become a VLSI designer, but getting that silicon implementation and testing the chip, and then you graduate, that only a few IITs can do, because not many second tier institutions can even afford the silicon chip implementation cost. It costs 2 to 3 lakhs to get every chip fabricated right now. And when it comes back, even the testing procedures, the testing facilities are not available in many institutions other than some premier kind of IITs. So that is one issue. And therefore, you might find PhD graduates who have designed something, but to find a PhD graduate who has designed, got it implemented on silicon and tested it, that you will find very few out of India, which is a problem. That is where academia industry interactions are very critical. For us, if many of these semiconductor industries get a lot of their designs implemented, if they give some silicon space for academia, and that way our designs can be accommodated there, and then
I will kind of
yes.
disagree with that point. Basically, I think putting the designs on silicon is no more unaffordable for these institutes, right? Because of the government support and the cost of these things have come down also, right? Quite a bit, right? I think the kind of the grants every institute get, right? Basically, I think they can easily afford siliconization, but basically, I think it's a more for overall capability issue also in addition to silicon cost. I agree with you. Maybe 10 years back, siliconization was very expensive and all of those things. But in today's world, if it takes basically 10 to 15 lakhs, I think all of these institutes get enough grants to do that, right? Basically, I don't see a single grant less than 3 to 4 crores nowadays, right? So I think we have the money in the system. We are not utilizing it properly.
Grass is greener on the other side always.
No. I am part of IIT Roorkee and I am basically seeing these things firsthand now, right? It's not basically any more industry, right?
Yeah, in 10 IITs, finding even that 15, 20 lakhs, because if I have 5 PhD students, and if each student needs to get one chip fabricated, it costs 2 to 3 lakhs. So now for me to allocate, let's say 15, 20 lakhs every year to keep sending out these chips, I can tell you, I can do it at IIT Delhi. Some people can do it at IIT Bombay, Roorkee, Madras, Kharagpur, Kanpur kind of places. But you go to other places, it becomes a bit of a challenge.
At least basically all the SMDP institutes, we can do it, right? I have studied this problem. Now we can do it. Basically 10 years back, we could not do it, but SMDP is putting a lot of money. And I think the government is also putting basically best of it forward. I think you talked about the startup also. So just I want to take 30 seconds to mention that the government is coming up with basically a very strong, fabulous incentive policy where they are putting about 1,000 crore rupees to basically help any startup, basically whether it's coming from industry or academia, if they are ready with basically a product which is worth basically taking to a commercial route through startup, will be supported. This 1,000 crore will create basically seed funding, pay for the growth stage of the funding, basically subsidize the cost of the chip when you go to the market because you may not be initially market competitive. And fourth is create infrastructure in terms of the EDA tools, fab access. So basically you can go any fab. And third big component is basically access to IP and compute infrastructure. So provide a common infrastructure in these 4 areas to any basically selected and worthy startup. So that next 3 to 5 years, we at least have 100 plus startups in this area, basically mushrooming. And that's the need of the hour, both for basically industry and academia.
Okay, let me bring in Preet here. Preet, yeah, go on. You were saying, go on.
So I have personally experienced the SMDP program when it started, I think around year 2000 back. And I was part of this SMDP phase 1 where the core IITs were the resource center and attached to this IIT Delhi was Siri Pilani, and I was at at Pilani and at Thapar. Both side I utilized the freebie the software tools as a part of SMDP part 1. And there that time it used to be a India chip program run by SCL Chandigarh, wherein the part of chips designs done in SMDP would were supposed to be get fabricated at SCL, but that meeting used to happen once in 2 years, and my design never saw silicon. Okay, but the facts have changed, as Satya was mentioning. Now the fundings are pumping in huge. But at the same time, we need to come with a mindset. Research and product. The commercial, they are altogether different. Okay. So wherever there are dollar associated, the research happens to double the dollars, or I would say triple the dollars every time. Whereas the research is to justify some uniqueness, differentiated solution than whatever is existing. Okay, it might not be that excellent use model product. So like I've seen people having a patent, a machine which can automatically change your bulb. Okay, excellent solution. But if someone asks me, pay 10,000 rupees to buy a machine which can change you 10 rupees bulb, I'll never buy it. So it's a good innovation. It's a patentable innovation and, excellent. But at the same time, it is not matching my, commercial market needs. Okay. So stepping back, let me mention this, all these thoughts, views are my personal and nothing to be, associated with the organization in particular I belong to or in general. So as you see, our daily lives have really changed. The technology has really shifted it. So the moment you wake up in the morning, your alarm is a mobile alarm, then the traditional, electromechanical alarm to the electronic alarm to a mobile device. Okay. So your walking and running pattern in the morning are now governed by your smart device. You don't wake up in the morning and say, okay, I'll go run to that particular 2 tracks in the jog and come back. Now your Fitbit tells, hey man, you are so many steps done and so many left. Okay. So to your heating system, and the moment you come back for a shower, to your television, to fridge, everything is smart now. Okay, everything is resolutionized. So if we see, we talk about industry 4.0, we started with industry 1.0 first industry revolution in 1800, wherein that steam power systems were there, and then industry second revolution came in, electrification, then automation, now industry 4.0, where everything is smart, everything is smart, the conventional devices. Now who brings this smartness? It is the silicon who brings the smartness. So if I have the best of the device with weight of 30 kg, I can't keep it in my in my pocket whole day and run around. So to miniaturize this, I need silicon. Okay, and that's how everything is now at the end getting to a silicon stuff. At the same time, I would like to mention, we as a Indian population, we are fond of skipping technological waves. We missed to reach out to every corner of India with a landline phone. We badly missed it, but we encashed it with mobile phones. Everyone might not have a good dress to wear, but would have a smartphone to make a call for. Okay, and similarly, I feel this is again our time. With all fabulated things going on, that we missed the first train, no doubt about it. Okay, and we know it was missed in front of our eyes. But we're not now gonna, encash the second train pretty well. The kind of motivations we have as of now. So gradually, I want to bring in the shift I have seen, at least in my couple of decades of career. Earlier, we were moving towards globalization. As Professor Rao said, the best in talent nurtured here, and then we are gracefully given it to the rest of the world to go and work in their factories and do the cutting edge work. But now, if you see, with all the trade wars going on, the US, China, and whatnot, everyone is looking back home and trying to be a self-reliant. So this Atmanirbhar is not only Atmanirbhar India, it is Atmanirbhar US, Europe, and whatnot. Okay. So for that particular challenge, and the schemes like the funding of 1 billion USD announced by government a week back, probably it's time for us to get back all those heroes, and instead of making in India, to manufacture in India. Okay, and the moment we start that, the Professor Rao mentioned, getting their designs in a shuttle, probably is no longer would be a dream we can certainly get into. Good shift from SMDP1 to now the new chip to systems. Okay, but certainly let us first get the chips in home, and then we'll gradually move towards the system. But I'm confident the moment we have chips of our home, getting to systems would not be a big race or a big deal from our side.
So what do you think? I mean, as an industry person, you've been there in terms of talent and all that. What more needs to be done?
In terms of talent, I would agree with Professor Rao. We are producing enough numbers. So if you go back in around year 2000 or up to around year 2005, the number of PhDs in core semiconductor were 2-digit numbers. It was not even a 3-digit number. Okay. And that time, all this SMDP and other initiatives came in place. And now, we have this 3-digit number, glorious 3-digit number. But the actual, the day one productive engineers are still, if you see in the percentage, would again fall in, that 2-digit number or early 2-digit number. So I feel, it's time. If you see, the technology is running pretty fast. It's like, blink of your eye, something new is happening. And so do we need to realize our curriculums. Okay, we can't sit on the old Vedas and do it for rest of the careers. So we need to shift the basic things, probably to say 10 plus 1 or plus 2 area, okay? And the advanced stuff should come in that 4 years of BTech curriculum. Okay, I still feel, there was a time where everything was taught by a textbook, okay? And now being a lot of data available over the internet, you need not to have those textbooks. But if you bring in the latest technology and, partnership with industry and academia, wherein, industry folks can go and spare their time, a fixed time, probably you divide the whole curriculum in 10 chapters and one industry person picks up one chapter, can bring up that, at least the 10% of knowledge inside the curriculum. So I think that is again a big shift which we really should do to, to move the basic things into +1 +2 side and get only the advanced stuff into a BTech curriculum to make it, day one industry ready engineers.
Okay. Professor Rao, you want to respond to that?
Sujit, is that I think a lot of academic institutions, including IIT Delhi, IIT Kanpur, right, have started this new concept, not maybe not so new, professor of practice, right? Okay. I think we should try to work between industry and academia more to make this practical. So that basically at least every academic institution in the respective area get 20-30 of these people, right? Professor of practice who can basically impart the practical knowledge to basically the aspiring students in the different fields of curriculum, right? I mean, for example, I have joined IIT Roorkee basically as they don't call it professor of practice, and just a visiting prof for whatever, right? So, but I see that basically based on my background in technology and industry, right? I think I certainly see I can bring some value and some different way of thought process in the academic systems, right? So I think if we encourage that thing more, right, I think that will help us in bringing the academia and industry together, because otherwise we have been talking about this subject for almost 20 years since I started talking on the public forum, right? Every forum has this topic, industry, academia, collaboration, right? I think this POP concept can really make a dent into that direction. Professor Rao, you can add more to it.
Yeah, Professor Rao, to the 2 points that Satya also made and Preet made, your response to those.
No, I think these are all valid points anyway. The one thing is, in India, somehow the bachelor's programs, the BTech programs are always associated with the communications. We always call electronics and communications. And recently I was advising some college, why do you want to call it electronics and communications? This is a historical kind of a thing. Why don't you call it electronics and VLSI? Make it a dual degree program, make it a 5-year program. And, you teach the student now within that 5 years, a complete electronics and the VLSI. I think you will have many more job opportunities than a very traditional electronics and communications kind of a program. But, many institutions are not willing to innovate, not willing to take any risk. Everybody is running electronics and communication. AICT also talked about electronics and communication. So we also should do electronics and communication.
Why was it called communication? Communication because as part of a telecom kind of thing, is it?
Historical
reasons, right? You need to have some DSP algorithm, basically.
Okay.
So I will try to bring in a point here. In my BTech curriculum, VLSI was only a transistor, only CMOS was taught, okay? And I didn't had any clue about VHDL, the language 2 decades back. And I was lucky enough to do my end college, project in VHDL language. So I got an opportunity to do my internship at Semiconductor Complex Limited, Mohali, the only fab of India, and gradually find out a guru there. And he guided me, and I brought up that book, which was not part of my curriculum. And I was the only guy in the whole 60 students batch who could do an end semester project in VHDL. And I was lucky, even the invigilator was not having any clue, so rated well. So we need to find out such gurus. I was really fortunate enough to get that guru. Okay, so now again that comes, that links the industry. Because I got a good opportunity, luckily to, do internship at SCL, and I was able to, prove myself in 8 weeks to get that connect and do my, do a project outside my curriculum. So we need similarly more of such gurus, even if we make it 10% of it in a year, we'll see a huge shift, just 10%. And that 10% for 3 years would do wonders.
See, every electronics course has this basically electromagnetic course, right? Which is most dreaded course. You get lost into divergence and currents and you never understand and never use it in your life, right? I think basically I 100% agree with Professor Rao that basically we need to bring I'm not saying make it very much like industry, but basically at least tune it to the basically today's technology, right? Yeah. I personally don't subscribe to the fact basically that engineers coming out of BTech should be day one ready for basically on the job, right? I think our job is to give them the good fundamental knowledge, and if it takes 3 months to them to learn those things in the industry, that is fine, right? But I think the technology has moved, but our curriculum has not moved. We are still basically trying to teach divergence and curls to people who are never going to use it, right? I think we just have to move out of it. And I think Professor Rao's suggestion is basically the excellent suggestion and one of the best I've heard. That let's make it electronics and VLSI, or electronics and basically nanotechnology, or whatever you want to broaden the scope, and make it broader beyond basically VLSI also, make it nanotechnology, right? So.
Yeah,
So I feel in this context, this national policy on education, where I think there's more liberty given to pick up some allied subject. So, sir, I would like to put in a suggestion that we did masters, after BTech in EC, electronics and communication, as you said, and then masters in VLSI design. So can we bring that, MTech, that M of that, as a part of final year BTech curriculum? So that it's BTech in electronics and specialized in VLSI.
That is what we call the dual degree, the 5-year BTech, MTech programs we have in IITs. But that is where, IESA working with some of the IITs, we can design a curriculum, which is electronics and VLSI, and a 5-year program, which many colleges can introduce. That way we will have so many trained manpower, to serve the industry, because from software, the natural extension could be VLSI. I mean, software now we have beaten it to death. I mean, what more you can do in software? So now I think every college now, finally everybody gets a job in software only, whether it is mechanical or civil or whatever. Now the next logical thing for us is the VLSI. There is still a lot of untapped market there. And that is also something which a good VLSI designer, I can tell you, I cannot afford my own PhD students. They graduate, I cannot hire them, because now they are getting my salary, half of my salary on their first month. Why would they come and serve me? I think within 5 years they all would be earning much more than what I would be making. So it's very difficult. And now imagine the condition of startups. Startups now have a huge requirement for the VLSI implementation of their designs, and they have nowhere to go, and they're all struggling. And I think this is the problem. Even in our institutions, if you see the VLSI, take the case of any of our good institutions, many students want to work in VLSI for the MTech program. Their projects they want to do in VLSI, but we have a very small fraction of faculty who have the VLSI background, and the majority of them will be, let's say, the electron devices in the microelectronics area. So most of the faculty are doing things which students want to do. Students don't want to do. That is a mismatch between the faculty expertise and the aspirations of students. And we are not able to do anything about it, because, we are competing with industries when it comes to hiring a good VLSI faculty. And
so how do you address that issue, Professor?
One way is, like what Dr. Satya Gupta is saying, the professors of practice is one thing, but it's also difficult because the good ones in big industries are all, from quarter to quarter, they are under tremendous pressure. Deadlines and, meeting their design deadlines and all of that. One way is also the joint appointment of faculty. There are many good people all over the world, but they will not come and join us at our salaries, which are quote unquote the government salaries. Can we join hands with industry, and then industry and academia recruits a faculty member with a 50-50 kind of an arrangement? The faculty member will be shared between industry and academia, and that faculty member can also be a bridge between academia and industry and gets decent salary, and then can bridge this gap. And I think that is what we need to promote in the country. Already some discussions are happening at the CII and other levels for such appointments. But I think if IESA also takes it up, and then if we can, because all of our institutions can do that. Maybe some institutions which don't have the autonomy might find it difficult, but IITs, I can tell you, if you say, here is a faculty member who we want to recruit, 50-50 arrangement, and that person is otherwise would not have come to India. I think through that kind of an arrangement, if we can get them, that will make a big difference. And also to increase the manpower, like what I was saying, designing a curriculum, electronics and VLSI jointly with IESA, and going to AICTE, make it as part of their regular sort of charter, so that right now I don't even think they will allow a college to start electronics and VLSI program, because that doesn't fit into their template right now. Electronics and communication is already pre-approved, but electronics and VLSI is a beast for them. They have no idea what electronics and VLSI is going to look like. I think we need to do some of these, because the manpower is becoming a big challenge. That is a rate limiting thing. And as Satya Gupta said, of course, in IITs, some silicon implementation, the doing things with silicon, all that is possible. But many people, even if they have money, not many people even have the expertise to design something on silicon. I can simulate something on a computer and simulate it with another tool and get a degree. But there are very few institutions where the student reaches a stage, gets it designed, gets it silicon implemented, gets it tested and improves the performance, shows a working chip. And that is very important, because industries, they cannot even afford they don't even have the luxury of trying it multiple times. For them, the first time the chip has to work. If the chip doesn't work the first time, and if they keep on trying, in the industry, the guy will have a big problem. So I think, yeah.
So I want to just basically make some commitment based on what Professor Rao suggested. Right? First of all, is that this professorial practice I'm emphasizing so much, because if you look, the VLSI industry in India now is about 35 years old, right? So a lot of people like me and my friends, right, are at that part of the career where we would like to devote our time to basically these kind of the activities. Some of them is kind of partially retired, some of them are on the way to retirement, right? I think if we can tap that basically pool of people, right, basically late 50s, early 60 type of people, right, I think they can very meaningful contribute to basically this journey of basically bringing the industry knowledge to the academic institution. Second is basically about the curriculum. I think let's make a commitment here, is that basically next 1 year, let's get it done, right? I'm with you. I'll basically work with you and other people, basically like IIT Roorkee, IIT Guwahati, IIT Kanpur. Let's put you, Abhay, and couple of other people together, and let's come up with basically Professor Bhaskar, and get it done. I will set up a meeting basically within 2 weeks to start the dialogue on that one.
So I have another point to make here, Sujit. I was not able to resist.
There are a lot of audience questions coming in, by the way. Okay, go on, please.
Output depends on the input, okay? And if your brightest students are picked up by the industry, okay, with all due respect to all the faculties here and my gurus, the remaining ones are doing then masters or PhD, and then getting into teaching profile. Can we make it lucrative job? And we have seen, there are examples in a few of the European countries where teachers are the most highly paid in almost all of the countries. Okay, so can we show them, the same kind of paychecks and same kind of career paths, because we lose them out to the Western world, because they see better labs there, better opportunities there. So probably that could be one of the game changers. And now seeing a lot of fundings, as Satya was mentioning, the minimum funding is tens of crores. Okay, probably let us start utilizing a part of it as an experiment. Let us try to see, can we retain our best top 5 guys, okay, and see how they proliferate for next 2-3 5 years.
Yeah, I think Professor Rao wanted to say something. That in their time, they used to look at the funding of 50 lakh, 1 crore. Now nobody talks of less than 10 crore, right? I think you only said in some of the place, right? So,
I think one point I wanted to make, we also need to realize that IITs implementing these programs, IITs will always be very small, high quality. That is the character of these institutions. Despite what you make us to do, finally, we will be so quality conscious that the numbers will never scale up. Our role will always be train the trainers, produce that very high quality, those 3%, 5% kind of graduates. For the VLSI to become prevalent in the country, that, so much is happening in the country, create that whole momentum, you need to involve the second tier and third tier colleges. That is what IT has done. What is that IITs have done to make IT a booming industry in this country? IITs would have done, may have produced one Nanda Nilekani there, one, another person there. But the IT in the country has boomed because of all these smaller colleges taking up these programs and churning out graduates. That is something that needs to happen with VLSI too, which has not happened. VLSI remained as a very top level, a few institutions doing that. And in the process, we have never been able to scale up.
And that will happen with what, do you think?
I think that is where we need to involve AICTE. We need to design a curriculum for electronics and VLSI kind of a program. And we need to now encourage more and more, these colleges to start these programs and do some hand holding with them, like the SMDP kind of a program, provide them some basic facilities, define some projects which they can do, involve the local industries as much as possible, at least, put some quality checks in that. And, once these graduates start to understand what VLSI is and that they are reach a certain stage, that is when the industry can pick them up, train them further. And even in the IT today, industries do provide a lot of training for the graduates who are coming out. I think the same thing, if it happens in VLSI, to me, that will change the course of the VLSI industry in this country.
Okay. A lot of questions, Professor. Shilpa?
This question is from Aditya Upadhyay. I'm a BTech graduate from the 2011 batch of an old IIT. I feel that even IITs have a very limited number of faculty and courses for system design and implementation. Most of the courses are in academic nature and not coming close.
Shilpa, I think we lost a little bit of what you said.
Yeah, so Aditya is asking that most of the courses are academic in nature, and how do you think we can make it more industry ready? How can we overcome this?
Actually, we have this challenge. I think the faculty thing is a big challenge, but there is, there are some top guys in the academia, and they would have got 10 times their salary if they move to industry, but they are still, for whatever reason it is, they are in our institutions. And, I think a lot of good quality work is happening, but like I said, the faculty recruitment is a big challenge in VLSI for all of us. If IIT Delhi and IIT Bombay and our top institutions are facing this as a challenge, imagine why a good person would go to any second tier or third tier institution. So I think that is a big challenge. We need to solve it through the kind of schemes that we are talking about, the joint appointments and professors of practice, more industry academia collaborations. I think, that needs to happen on a much larger scale, right?
Shilpa?
And still questions are queuing up, Sujit.
Okay, this one I have, you kind of answered this question. So, Sai Akhil asking, sir, I'm a final year engineering student. My passion is to pursue my career in the VLSI domain and plan to do an advanced diploma in layout design. Is this the right time to enter into VLSI industry? Of course, you said that, absolutely.
So let me try to answer this, so in industry, we need all skills, it's not only the layout he's specifically asking for, but, from the circuit design, I come from analog and mixing background, so where layout is, very crucial, creating a good analog cell layout. But yeah, it's the right time to pick up any of the skills in this domain. We are in thrust of almost all those skills. And as Satya mentioned, 15K per annum. So if you miss the train this year, there's another 15K lining up next year. Because luckily, every big brand in the semicon domain has a design presence in India. Okay, so they would be certainly looking for one or the other tree. And second is, more understanding about the fundamentals. If your fundamentals are good, you may become from layout engineer to a circuit design engineer and vice versa. But if you haven't worked on the base, the first layer, then whatsoever add-on you got on today probably would help you out for next 5 years, and then gradually you'll lose out the league. So I would stress more on the fundamental, spend 2x time in the lab probably would be the key.
Okay. Also, I would like to add to this, there is also the startup thing, which we are missing out heavily in the VLSI domain. To start a company today, what do you need? You don't really need any major expertise. You don't need a foundry or anything to start a company in VLSI, because nobody does their own chips. They design the chip and get it done by one of these foundry service providers. So I think now identifying a right problem, designing a chip which has specs better than what they exist today, that sort of an expertise, if 5 people coming together can start a VLSI company, and if they can produce some IP, own some IP, they can become much bigger companies in the near future. That is also one thing which is not happening enough, because we don't have enough graduates, and those who are there, they're all getting picked up by these big industries at high salaries. And I think even the startup thing we are missing out in the VLSI domain. And I think even from that point of view, we need more and more trained people who can get into the startup space and start designing the next generation chips, and whether it is for IoT,
Just
sensors.
comment on this startup thing, right? I talked about this fabulous initiative from the government, right? Basically, the fabulous startup ecosystem has not picked up as much basically as it should have picked up. See, if you look from 2000 onwards, there was a basically dull period around 2008 to 2012, where basically semiconductor fabulous startups were not flavor of the month, right? But I think last 7-8 years, with the basically AI, ML being at the forefront and so on and so forth, I think it has become this thing. But problem with fabulous startups, unlike a software startup, fabulous startup requires basically significant amount of investment, even if basically you are not fabricating your own chip, right? It basically ranges somewhere between $2 to $5 million compared to a couple of 100,000 basically which may be required for the startup, right? And that's the reason we worked with the government to come up with this fabulous basically startup incentive policy to push basically this initial funding barrier out of the way, and the kind of the things they need, so on and so forth, right? So if I look at the typical fabulous startups today in India, right, they're all underfunded. Okay, something which they could do it in 3 years, they take 6 years to do it because they don't have the sufficient funding to do it. And if you do it in 6 years, then most of the time you miss the market, right? Because this is fast moving technology, something which needed to be done in 3 years. You don't have money, you end up doing in 6 years, you end up losing the market window also. So I think that problem is very critically recognized both by the government and basically industry. And that's why hopefully basically within 2 to 3 months, you will see this policy come, and then the meaningful products, right? I just want to bring one more point here, right? Whenever we think of electronics and semiconductor products, right? Everybody thinks bleeding edge, right? Oh, I want to do basically 7G type of the thing or this thing. But in India, if we look, there are about 10 products which are very critical to the national infrastructure, from basically security, economics, and so on and so forth, right? There, the technology is more or less known, okay? If you can put together some good program working with the government, industry, and academia, to give a simple example, right? A Wi-Fi chip and a system, right? Now, professor basically knows a lot about communication, algorithms, and so on and so forth. So Wi-Fi technology is more or less known, right? We just have to put a basically good program together to produce basically Wi-Fi 6 type of the chip, which does not require bleeding edge technology. It can done basically reasonable thing and make a system. Now you have a PM Vani program, which is basically waiting for these kind of the products, right? That will basically create a jump start for the rest of the industry. If we take products like Wi-Fi, products like smart meters, Why do we have to basically depend always on the chips for a smart meter from outside, right? This is something which can be very well done. Both academia and industry knows how to do it. We just have to consolidate our resources and put a nice program for this 10 odd basically products where we can go really chip to system or silicon to system, whatever we want to call it, right? In a real meaningful way, open it for everybody, define the program, let people come up with competing ideas, pick up the best, give the project to those people and let them basically design chip and the system both. And we already have the market, right? Like I said, PM Vani program for Wi-Fi, educational tablet for education. We have requirement of 250 million smart meters. There are 10 such products which can really make the Indian semiconductor electronics product, right? We are already doing other manufacturing or we are doing services, right? We need to put the focus back on the products, and these type of the ideas can really give a bootstrap to basically the product innovation and product creation in the country.
Okay.
This question.
Okay. We're running out of time. Yeah, Shilpa.
Yeah, we have this question from Vamshi Gaud. Curious to know, what is the salary of VLSI engineers? Is it more than software? If yes, then why are more students moving towards IT as VLSI is imminent to the future?
So Shilpa, it's not about the salary only. So it's about, how well you are a fit, To be a software engineer and to be a VLSI engineer are two different things, okay? And as Professor Rao said, it's easy for him to recruit a software faculty than VLSI faculty. And same goes the, studies or, the kind of, I would say, depth you need to get into for the subject, okay? The deeper it is, the wiser it is, okay? And that goes with the software or IT. And as we were discussing at the beginning, I know in my college itself, for the software and IT companies, even the biotech guys, people who were doing BSc biotech were eligible to, write the entrance exam, mechanical, civil, and whatnot. Okay, but that was not true for the core VLSI semiconductor companies. Okay, and then the same is vice versa is the paycheck in general. I would call. Okay, so the deeper you go get into the fundamentals, I would call it, the better impact probably you will make it to your paychecks.
Preet, there's a similar question actually. This from Rajani.
I'll just add to that, Shilpa, is that basically it's a high risk, high reward, right? Basically, you have so many more jobs in the software, so chances of getting a reasonable medium salary job is much higher than getting a high salary job in the VLSI, because this being a premier basically field, companies will be selective, right? So it's a basically high, any other thing, high risk, high reward type of the situation, right? You can average game or you can play in the high, basically risk, high reward area, right?
Something similar, this Rajani Pashikanti is saying, is an MTech in VLSI design, saying the placement cells in colleges encourage students and train them only to take up software jobs as they come to institute and pick them irrespective of course we study. How can this trend be changed?
What do you want
it's like, you need to be in the right league. Ultimately, if you, I remember in many of the good institutions, I was at IIT Roorkee almost 10 days back, and during the lunch meet, I had this question about the placements, and they said we had an excellent placement in COVID. And I asked them this question, do you charge for the first slot? Okay, because everyone would like to chase down or pick up the cream in the first slot, and they said we don't charge, but there's a lot of competition to get into the the first slot for any of the good institution, I'm sure, including IIT. And there are people who skip this first thing because they are not willing to settle for less, sitting in a software company, with all due respect to the whole huge software market. Okay, so it's easy to get into software relatively. It's like getting to VLSI is a marathon, and getting to software, I feel, is a 100-meter sprint. Okay, so you need to build that stamina to run the marathon to get to those rewards. Professor Rao.
I think just to add to that, the way our BTech curricula is all done right now is as it exists today. You cannot become a VLSI designer with just a BTech degree in India. So you need advanced training. you need to do MTech, and that is where MTech programs are very heavily subscribed. For example, to get into a MTech microelectronics VLSI program in a top IIT will be like 99.99 kind of a gate cutoff scores. And because there are so few programs, but you know that once you get to those programs, then your life is set. After that, you will become so much more in demand and all of that. But so therefore, VLSI requires additional training. With just existing BTech curriculum, you cannot become a VLSI designer, unfortunately. That is what I am suggesting we need to change. So you can become a IT engineer with just our existing BTech degree and with a short-term training. Why can't you become a VLSI engineer, at least in some basic levels with a basic curriculum? So that is where we need to modify the curriculum. That is where a 5-year program, 4-year program may be too much to pack so many things, but a 5-year dual degree kind of a program offered by many colleges with advanced training in the VLSI areas, I think that can be a game changer for the country.
And at the same time, Sujit, just to add up, everyone is busy about numbers. So probably the TPO, would want to make his numbers, and it's easy to make those numbers in software,
See, another thing which I'm finding is that basically if a VLSI company goes somewhere, right, they are going to pick up 3, 5, 7, 10 small number, right? They're never going to pick in hundreds and so on and so forth. So that's why if I'm company X, right, let's say Preet's company, I can afford to go only 7, 8, 10 campuses, right? I cannot afford to go to 100 of campuses. But one thing which is very unfortunate, right? Couple of basically places when I had interacted with the students, right? With all the basically power of internet and information in their hand, right? They're not doing their homework to know about what is there in the industry, right? Which are companies which are basically big in India, right? If you ask them in one of the basically colleges, I went like second tier type of the college, I asked that basically what are the top 10 companies you think basically you can go? It was hardly anybody answered that question, right? I think with so much information available, since the numbers are low, you cannot expect basically every VLSI company to go to every campus. That is basically going to be practically cost prohibitive. So students also have to reach out to companies basically through the information. The jobs are published in portals of the companies and so on and so forth, right? So I think my suggestion to the audience, if there are a lot of students, is that guys, internet something beyond Netflix also. You can use it for something beyond Netflix, right? So
approach them directly. Okay.
Okay.
Yeah, one last question from Shilpa, then we'll close this. Yeah, we are run out of time. Yeah.
Gaurav Sharma, can you please throw some light on research PhD programs? I think we should focus more on research instead of just focusing on MTech and getting jobs.
Yeah, I think Satya wanted to ask that to you, Dr. Professor Rao. Research.
MTech, the PhD programs are in great demand. If you work with a good person in this area, I mean, a lot of things can be done. I mean, it's a wide open area. Like I said, the problems are very interesting in this space, and you can work on even electric vehicles, which will have a lot of different chip requirements. You can work in agriculture. I have students working on developing sensor systems for agricultural applications, and everything is an ASIC, everything is in a application specific integrated circuit. And again, there is a lot of scope that is there. And similarly, security, can you have sensing platforms for taking care of the security related issues, like I mentioned, the explosive detector on a chip. So I think there are infinite problems to work on. And I think joining a PhD program to me is a best way to enter industry at a certain level and with a certain career path. MTech is good enough for some, but if somebody is research minded, research oriented, I do suggest one should do a PhD in this area. Then you become good at one area, and then from then onwards, life the career can take off. And that's what I advise for people wanting to get into the VLSI things. I think you need some advanced training. You cannot just rely on a 4-year BTech and expect to become a great VLSI designer.
I want to add a little bit flavor to this. I think when Professor said sensors and all those things, right? I think the research in this area is going way beyond basically traditional CMOS and those logics, right? Basically, there is so much opportunity in the sensor area, which can utilize different type of the technologies. There is so much potential for basically creating large heterogeneous integration, right? Uh, the whole paradigm of the computing on silicon is changing, right? We are no longer basically processor centric architectures, right? We are basically becoming non-processor centric architecture, compute memory, and so many new things are opening up beyond basically typical silicon applications, right? I think both for the PhD student and rest of the research, right? If we take 5 or 6 or 7 of these problems, right, and have a concerted effort in this direction, I think we will produce better people as well as we will produce the research, which maybe in 10 to 15 years will take us towards basically some idea of self-reliance in this area, right? Because I think silicon is coming more towards an end and it's become more of an engineering problem than an R&D problem. And R&D also is basically very expensive. The TSMCs of the world can basically afford, right? But there is so much opportunity in the sensors and alternate devices and alternate technologies. I think that's where we can focus in our R&D initiative, if I may so propose.
Thank you all so much for a wonderful discussion. I think it's a segment that looks to be in the beginning of a major takeoff period. So it's beginning to get a very exciting. Frankly, the number of discussions that we had with IESA itself over the last few months shows, I think, the kind of initiatives the government is taking suggests, and as Preet also said, the whole deglobalization in some sense, the Atmanirbharta, etc. This industry is definitely at the beginning of a major takeoff, and some wonderful suggestions came through. Professor Rao, you should hold Satya to his promise of helping you with the faculty and all of that. He said the industry will help you with funding faculty. That's a great suggestion. And thank you all once again. Great discussion. Professor Rao, Satya, Preet, thank you.
Thank you. Thank you, everybody. Thank you to all the audience also.
Yeah, thank you.